Hello, I'm going to do another one now. So, another request was number 10, circle theorems. What a surprise. Do we have to? Right, so A, B, C, and D lie on a circle. A, C, and B, D intersect at X. Explain why ABX, which is, let me draw it out. This looks like this is a classic. Why they're similar, I'll show you why. So, first of all, they share that angle. So, and you'd probably need to actually, write that out. So A, X, B, notation is everything here, equals D, X, C, because they're vertically opposite so descriptions are really important. They're vertically, I'm going to run out of space, aren't I? Opposite angles. This is the second one. They share an arc here. So let's go to, I've opened up the circle theorem sheet that I gave you in class. So it's actually this. So the angles in the same segment from a common chord are equal. So let's go back to that. They share this chord, and then those two parts are equal, and these two parts, bottom, are equal as well. Right, so let's have a look and see if that matches up. Yes, sir. So they share a common chord, and you've got one triangle there, and you got another triangle there. So therefore, that angle and that angle are the same. And if those two angles are the same, then these two angles have got to be the same as well. So in summary, so if you have all three angles in the triangle are the same, then the triangles are similar. Okay, BX equals 2 centimeters. So let's put that in. So BX equals 2. So I would annotate, if I were you, CX equals 4. The CX is done different colours. So CX equals 4. And the area of the triangle is 4.5. Or what triangle? ABX. Okay, fine. Right. Now, bearing in mind that these are similar shapes. So, why didn't I keep those angles in? So that's the same as that. That's the same as that. And then, don't know what color to use, that is the same as that. Okay, so the similar lengths then are going to be or the lengths we can compare are the ones which, run from the same at two angles. So from purple angle to the yellow angle, from the purple angle to the yellow angle. So they're given enough information here to work out the scale factor. So remember from all those years ago, scale factor is big over small. So the big side is 4, the small side is 2. So it is 2. So it's 2 times bigger. And we're working out area. So it's area scale factor. So recall we've looked at two lines. So we've looked at linear scale factor, area scale factor. As soon as we're working with area, is linear scale factor squared. Everything becomes squared. Think of the unit, centimeter squared. So actually, even though the lines are 2 times bigger, the area is 4 times bigger. We are going from, so triangle ABX is the small triangle here, and we're trying to find the bigger triangle. So you're going from the small one to the big one, so you just got to do 4.5 times 4. It's going to be 4 times bigger, so it'd be 18 centimeters squared. So we got a cyclic, I still can't remember, quadrilateral. Yep. RS, have they given us that? RSQ nonsense? Oh, I don't know. What? Yes, they have. So they've already annotated that. That's nice. PRQ, presumably. Yeah. Find angle PSQ. So let's start there then, shall we? So PS. Where's Q? There it is. PSQ. So we're looking to try and find that angle. Right. So, looks very similar, weirdly similar, using the same circle theorem twice. That's crazy. So they're sharing a chord. You've got one triangle here from those 2 points, and you've got another triangle. Therefore, those angles are the same. So that's 50. So the other green angle is 50. That's easy. Right. So 50 degrees. Calculate angle PQR. I'm going to rub that out. So first of all, identify the angle. So PQR. I'm going from P to Q to R. So here we go. And well, I know that's 50. This is really familiar. Have we done this before? Getting deja vu. This is really familiar. Okay, so all of that then is together 82 degrees. It's a cyclic stroke cyclic, whatever, quadrilateral. So you have to recall, I hope, that opposite angles add up to, remember, defined by every point being on the circumference. Opposite corners add up to 180 degrees. So if that was 82 degrees, 50 plus 32, you've just got to do 180 minus 82 to work out the other angle. So that, I do believe, is 98 degrees. So, yeah. Right, PR and QS intersect at the right angles at Y, and QR equals 8. Calculate the... let's annotate all this. So I'm sure we've got some useful information here already. I'm just going to rub it all out. Okay, so what is it again? PR and QS intersect at right angles at Y. Do they now? PR. Calculate the length of RY. Oh my god, what's going on? Right, so RY is here. Oh, it's Pythagorean. That's not. Sorry, it's SOHCAHTOA. So we got a little baby right angle triangle. There it is. So that is 50. This is 8. And we've got to find this. I'm going to call it X. Why not? So SOHCAHTOA. You remember whenever you got a right angle, you need to think SOHCAHTOA or Pythagoras probably. And label it. So we've been given angle 50. So opposite that is, funnily enough, opposite. Then this is the adjacent, and that is the hypotenuse. Hypotenuse always opposite the right angle. And we've given that, and we're trying to find that. So we're looking at hypotenuse and adjacent. So tick hypotenuse and adjacent. We can clearly see it's going to be K then. So let's label that nicely. So adjacent and hypotenuse. So it's cos of the angle 50 equals the adjacent X over 8. So to find X, we just need to multiply both sides by 8. So it'd be 8 cos 50. So I guess we have to work that out, do we? 8, go to your trig, cos 50. Make sure you're in degrees, of course. So 5.14. Let's just do a quick check to make sure there are no silly mistakes. Look at the mark scheme. So 5.14 centimeters. But yeah, let's just quickly delve into the mark scheme. Make sure there are no errors here. So 514, 98, and 50. So yeah, all good. And yeah, 18 for the other. Okay, right. Write down the size of the radius of the circle that can be drawn through. We definitely Q, R, and Y. Write down the size of the radius of the circle that can be drawn through Q, R, and Y. Oh, there we go. So the radius would be 4. So going through those points, the diameter would go across there. We know the diameter is, sorry, use a different colour pen, 8, so the radius would be 4. So that's it.